This is ENME 351 Lab 4 Exercise 1. I have my Arduino code here, starting with my serial.begin at the correct frequency, followed by setting my pin modes to be inputs. I initialize a delta variable and create my string from the end scope, which I'm going to be printing through serial later. I also describe a signal frequency by reading in from pin A2. Then I create a delta variable, which is 1000 over the signal frequency, which I then change to be in microseconds by multiplying by 1000. I print the end scope and I delay the appropriate number of microseconds. Following that, I have my screenshots. This is for my signal frequency of 100. And as you can see, I have sampling frequency of 100. You can see I have the signal frequency of 75, 100, 215, and 300. On the next one, I have my sampling frequency of 142, and again 75, 100, 215, and 300. Sampling frequency of 200 in the same order. And finally, sampling frequency of 500. Okay, following that, I have my table here. It's a bit hard to see based on the light, but this is it filled out fully, including for a variety of them. I had to use a folding diagram technique in order to calculate the appropriate theoretical alias frequency. This is my lab for exercise 2. As you can see, my end scope is creating a square wave on P1 and a triangle wave on P2, or on A1, sorry. Over here we have my potentiometer set up to my Arduino, as well as our end scope. I'm sending my A1 and P1 to channel 1 and channel 2, as well as currently reading into pin A1 my square wave. Sorry, my triangle wave. And you can see that here in the VSA. And this is interesting because it's getting peaks at 0, 10, 30, 50, it looks like. Slowly decreasing peaks on every 20 hertz following 10 hertz. I believe this is because the frequency is set at 10 hertz and the Nyquist frequency for this signal, or the Nyquist rate, would be at every 20 hertz following that. And if I switch this over to the square wave, you can see the VSA updates like that, and I get a very similar frequency graph, expanding out a little further than the triangle wave, but on the similar pattern of every 20 hertz following 10 hertz originally.